Hi, my name is Abid. It is EE314 Digital Electronics Laboratory course, and we are doing our project. Project is FPGA implementation of simple quality of service-based queuing. Project is done by a group of 3. The others will talk later. So basically, let's pass to the project. The basic diagram is presented as shown in a slide. So we have in our system we have 4 buffers, and we had to separate we had to spread packets between those 4 buffers based on 2 criteria. The first criteria is that we have reliability. Reliability implies that we should avoid dropout of a certain packet, and in this case, preference is given to the 4th buffer. So we should avoid dropout of packet from buffer 4, and then after buffer 4 comes 3rd buffer, 2nd, and lastly it's 1st buffer. And the second criteria which we have to consider is latency. Latency means that whenever we have some packet, we should read it. So the preference here is given in reverse order. So first privilege is given to 1st buffer, then 2nd, then 3rd, then 4th buffer. So whenever we have some file in the some packet in the 1st buffer, we try to read it. And in order to implement those principles, we had to design an algorithm. And algorithm will be explained by my friends. So I pass to them.
Hello, my name is Emir Alp AYAR, and now I'm going to talk about the first part of our state diagram. So we get our inputs from the FPGA buttons, and after input we press start button. The input we get is in the form of B0, B1, B2, and B3. B0 and B1 are the header bits. So according to their states, if they're like 0, 0, 0, 1, or 1, 0, or 1, 1, we decide our buffer. If it is 0, 0, we go to buffer 1, 0, 1, buffer 2, 1, 0 is buffer 3, and 1, 1, 4 is for buffer 4. So after we get, as an example, if we get B0, B1 as 0, 0, then we look which box is free to fill. If box 1 is occupied, we go to box 2. If it's occupied, we go to box 3. If it's occupied, we go to box 4. But then if box 4 is not occupied, we assign B2, B3 bits in decimal form to box 4. Or if box 4 is occupied also, we go to box 5. And then if it is not occupied, we assign B2, B3 in decimal to box 5. If all the boxes are occupied, we assign box 2 to box 1, box 3 to box 2, box 4 to box 3, that goes on. And then lastly, B2, B3 in decimal form to box 6. Now, my friend will continue with the second part of our state diagram.
Hi, my name is Mustafa Tekin. Now I will explain how we created our algorithm for buffer read. Firstly, to read the buffer, we'll look at the buffer 4. If buffer 4 has all of 6 packets occupied, then we will read the oldest item of the buffer 4. But if it is not occupied, then we will look for buffer 3 until we go buffer 1 with same logic. The reason we go from buffer 4 to buffer 1 is obvious, because we have reliability condition. So if none of the buffers are occupied, then we will look for the first condition, which is the latency condition. Latency condition implies that we need to read from buffer 1 first up until buffer 4. So if none of the buffers are fully occupied, then we will look for buffer 1 and read from the old first item of the buffer 1, and we will read the buffer 2, buffer 3, and buffer 4. Thank you for listening. This is all of the project.